Hello, and welcome to Automating Schema Management using JCL Scripting by Tim Welzer and Jay Chung of Broadcom. This slide shows our standard disclaimer page, which I will not go through, but that you can read on your own. When I say automating schema management, I'm really referring to what is commonly called DevOps, that is, development and operations. A DevOps for Db2 process tries to solve the problem of automating the management of Db2 object changes across multiple environments and enabling a self-service capability for developers while minimizing DBA involvement. Ideally, a DBA or administrator should only need to focus on the needs of the production environment. To address this problem, we have published an enhancement PTF for the CA Migrator and RC Compare products to help guide you in the building of your own DevOps pipeline. The enhancement includes a set of JCL templates, a sample DevOps workflow implementation using JCL, and documentation describing both a JCL and open source tooling approach to building your own workflows. By open source tooling, I mean using open source tools such as GitHub, the Zoe CLI, Jenkins, etc. This presentation focuses on the JCL approach. We also have a companion presentation available which shows the use of open source tools. Let's begin with the JCL templates that are delivered in the PTF. The templates are building blocks used to create a DevOps workflow. They are designed to be used with an Apache Velocity compatible template engine, but for our purposes, they serve as JCL models used to create a JCL-based workflow. The table shown describes each of the templates, including their inputs, outputs, and the Broadcom CA products used. The first template is used to generate DDL for selected objects from a source subsystem. The second template is used to validate DDL syntax due to changes that have been made to DDL. The third template is a multi-step process. It creates a compare strategy and analyzes it to produce an update script and an incremental change report. The update script is a batch processor script that performs updates to a subsystem. The ICL report is a terse form of the update script. And finally, the fourth template is used to execute the update script generated by the third template. Let's take a deeper look at the first of these templates. For the most part, it looks like normal JCL, but with some extra syntax sprinkled in. As you can see, the template executes the CA Migrator product using the DDL only option, meaning only DDL is to be generated for selected objects. Object selection criteria is specified as part of the parameter file input to an RC Migrator quick migration. You have the usual JCL variables, which are prefixed with an ampersand, and some of which are substituted into the in-stream parameter file read by RC Migrator. You can also see the Apache Velocity compatible variables, which are prefixed with a $sign. And finally, we have the template engine syntax statements, which are prefixed with a pound or hashtag character. When using the templates as JCL models, the template engine syntax is replaced with appropriate values. Before talking about the sample JCL we provide, let's take a quick look at an example of a typical DevOps workflow. In this case, we are working with three environments: development, production, and QA. The first step is to provide the development environment with the current state of the objects from the source production environment. To do this, DDL is extracted for objects from the production environment and used to update the target or development environment using the first, third, and fourth templates. A developer will then make application changes along with Db2 object changes and update the development environment as well as test the changes. The developer can repeat this cycle as many times as needed. When the developer completes his update and testing, he then promotes the changes from development to QA in the same manner that the development environment was provisioned from production. The quality assurance engineer can then test the changes and either accept or reject them. A rejection returns things back to the development environment for corrections. If QA accepts the changes, then they are promoted from QA to production, again using the same process that was used to promote the changes from development to QA. It's at this point that a DBA or an administrator can be notified to give the final approval before the changes are moved into production. Each of these mini workflows can be implemented through a series of JCL steps by customizing the templates and incorporating them into a JCL procedure. This gives a developer self-service capabilities and can insulate him or her from having to know implementation and product details. The RCM enhancement provides a sample of a workflow that promotes object changes from one environment to another. This sample can give you an idea of how you can build your DevOps pipeline using JCL. The enhancement consists of a PROC and 2 JCL jobs. The RMAPROMP PROC is a multi-step procedure that does most of the work and hides the details. It generates DDL for selected objects, then compares it to the objects in a target environment to create and analyze a strategy, which produces an output update script to make the target look like the source. It also creates an ICL report for a review showing exactly what changes are being made to the target. The RMAPROMJ job submitted by the developer merely invokes RMAPROMP procedure, identifying the objects that are being changed along with the source and target subsystems. The RMAPROMX job, submitted by the approver or DBA, reviews and executes the update script that was generated by the RMAPROMJ job. Here's a quick look at the PROC and JCL themselves. First, there is the simple RMAPROMJ, which is submitted by the developer. It invokes the RMAPROMP procedure, passing the inputs of a source and target subsystem and the developer's email address for notifications. The other input provided is an object selection specification used to identify the objects to process. The RMAPROMP PROC has a set of one-time configuration parameters, and it captures the values supplied by the RMAPROMJ job to do its processing in order to create a script to update the target environment. When the RMAPROMJ job completes, the DBA or administrator can review the changes to be made and simply submit RMAPROMX to update the subsystem. This slide enumerates the steps performed by the RMAPROMP procedure. The significant steps are copy object selection to a temporary file, generate DDL for selected objects, create a compare strategy between the DDL and the target subsystem, analyze the compare strategy to create an update script, generate incremental change language report, and email a request for approval to the approver with attached details, the update script, and the ICL report. The input requirements are minimal. The output is kept in ZOS datasets as well as being emailed to the reviewer. And there are just a few one-time configuration values. In addition, a DBA or administrator might want to make other product-specific configuration changes, such as including or suppressing report headers, etc. Here is an example use case to promote Db2 object changes from a QA to a production subsystem. The diagram shows the changes made to an existing Db2 hierarchy. New objects are shown with dashed lines, such as a table, a trigger, a foreign key. Existing objects have solid lines, and new attributes that are added to the existing objects are shown in red. So, what needs to be done to promote these objects from QA to production? The execution of two jobs. The developer submits RMAPROMJ, supplying appropriate values to generate an update script. Then, the DBA administrator submits RMAPROMX to implement those changes by executing the update script. This shows the simple RMAPROMJ that was used to start the promotion process. Only the database needs to be specified because the PROC has been pre-configured to include related dependent objects. Execution of RMAPROMJ produces the update script, a snippet of which is shown here. You can see that the update script includes create statements for the new objects and alterations to some of the existing objects. The additions of a column to the existing index required that it be dropped and created with the added column. RC migrator analysis tries to be as least disruptive to the subsystem as possible. This shows an approval request that was sent by the job to the approver informing him or her of the changes requiring approval. An update script and an ICL report are attached. In this case, the email also provides the details that the approver needs to submit the RMAPROMX job. Snippets of the ICL report are also shown. The ICL report provides a terse report of the changes that will be made when the update script is executed. Unlike the analysis report, there are no utility calls generated. You can see that ICL alter statements are used, identifying exactly what changes are being made to existing objects. Here we show the simple RMAPROMX job submitted by the approver or DBA, which is used to execute the update script, supplying the values noted in the email. This helps to reduce and simplify the DBA's effort. The result of the execution are emailed to both the developer and the DBA with a recovery script and execution log report. The recovery script can be used to back out changes should it be necessary. Here is a snippet of the recovery script showing new objects being dropped and existing objects being altered or created without the changes. And here is a snippet showing the execution log. And of course, now the objects have been successfully promoted. A DevOps pipeline is not constrained to do only DB2 schema management. Here are a few ideas of other things to include into a DevOps pipeline. Things like provisioning your environment with test data, provisioning the environment with production DB2 statistics to tune your SQL queries using Explain, maintaining a DB2 application in sync with the DB2 object changes, recording and reporting DB2 Explain results, comparing Explain results between development and production, or backing up and building a changed DB2 application. That is pre-compiling, compiling, linking DB2 binding, enforcing standards, tracking DevOps activity, archiving DB2 DDL, application source and build processes, etc., etc. Thank you for taking time to view our presentation.